Hi, iSTEM students. Today we want to talk about graphing acceleration. So you can see on the front page here, we have a comparison of a position versus time graph and a velocity versus time graph. So that's really what we want to start out with. So the y-axis on a velocity time graph shows velocity, and the y-axis on a distance time graph shows distance. But the big thing to realize here is that that velocity time graph is going to actually show us acceleration. The slope of the line there will be the change in velocity over the change in time. So a velocity time graph is used for acceleration, and a distance time graph is then used for velocity, like we talked about before. So what does constant motion look like on a distance versus time graph and a velocity versus time graph? So you guys are going to drag and drop some stuff onto your slides to put the things that we talk about here in the right spots. But if we think about this, these two graphs here, first of all, we have two graphs, but we don't have any axes. So let's get some of that stuff put on here. So on the left, let's have our distance versus time graph. So we'll have distance on the y-axis and time on the x-axis. And if we're talking about constant motion, that means that I have to have a constant slope. So we're going to have that constant positive slope to indicate that we have an object that's moving away from the starting point at a constant speed. On our second, again, that's kind of what I just said here. We wanted a constant motion away from the start, positive direction. So again, you guys are going to want to type that in there. And we can always, again, calculate that velocity like we talked about before by taking our distance divided by time. So our arrow shows us that we get to, well, maybe close, about 2 meters in 2 seconds. And so that's going to be a velocity of 1 meter per second. How is this going to look on a velocity versus time graph? So if we put a velocity versus time graph over here on the right, now we have to think about the fact that we are moving at a constant velocity, and we want to measure that velocity over time. And so this would actually just be a horizontal line where we would have that constant velocity going over time. And so again, a constant motion away from the start or in the positive direction, and it's going to be constantly at 1 meter per second. So notice that when we have a constant motion, we actually have a flat line for our velocity versus time graph. These are describing the same motion. They don't look the same on the two graphs though, because of the fact that the two graphs are graphing different quantities. Okay, so let's think more about velocity versus time graph. On a velocity versus time graph, a horizontal line can actually show us two things. It can tell us two different things. So one, it can tell us that there's no motion at all. And two, it can tell us that there's constant motion. It all depends on where that line is. So if our horizontal line is on the 0 meters per second, well, that's going to be no motion, zero speed. But if the horizontal line is at a number greater or less than 0, that is going to tell us that we have a constant motion happening at that speed. So let's look at a situation here. A person is standing 2 meters from the origin and not moving. And so we want to think about the lines that we'll have on our graphs. So again, let's think about a distance versus time graph. They're standing 2 meters from the origin and they're not moving. So we're going to initially have this line here, okay? That's just a horizontal line because their distance is not changing over time. Their velocity is 0 meters per second. Again, zero slope on that distance versus time graph means that it's zero velocity. But again, what does this look like then if somebody's standing still in terms of a velocity versus time graph? Well, are they accelerating? Well, no, not really, because not at all, because they're not moving. So that would just be down there at the 0 point that we would have a horizontal line, and that would be indicating that the velocity was 0 there. Okay, let's take a look at a couple other things. So if we wanted to kind of start to sum things up, we have really 3 types of acceleration, and how they will look on graphs will be different. And so if we think about our first one here, constant acceleration, Constant acceleration will show the same change in speed over time. We will have the same amount of time that occurs, and so we'll see a constant slope that's happening here. Okay, so if we have a change in a constant acceleration, we're going to have that same change in speed over the same amount of time. And our red line and our blue line both show this, okay? So it could be that we have it going downward or going upward. And we'll talk about that in just a second. So get those things dragged into your spots. Another type of acceleration then that we've talked about is negative acceleration. And so that's really that downward sloping line. And that means that we have a decrease in velocity over time, also known as slowing down or deceleration. So negative acceleration is slowing down or deceleration. And so you can tell again, and if I grab my cursor here, we can kind of tell here, get my pointer, we're starting out at 4 meters per second and we're ending up down here at 0. So we have to be slowing down over that time. And so a downhill line is always going to show us that. Another type of acceleration is zero acceleration. And so zero acceleration is where there is no change in velocity over time, meaning we'll have zero slope. So this is shown as a horizontal line, and this would be something like a car having its cruise control on. The last type of acceleration will be positive acceleration. This is where we have increasing velocity over time. In other words, something is speeding up. Okay, something is accelerating. They're pushing on the accelerator in the car. Okay, and this is represented by an uphill line. Now, some of you might be saying, well, but you can accelerate when you are turning also. Okay, so how does that look on a graph? Well, that's much more complicated. And so we're not going to worry about that here. We're really going to think about things just kind of in one dimension and that they're not turning at all. But it is important to realize that turning is another type of acceleration. It's just pretty hard to show on graphs like this. So let's do a little review here. Okay, notice that we have a position or a distance versus time graph. And we want to think about the motion of the object just in that graph. So in the first segment of this graph, we have an object that's moving away from the starting point. At part 2, they are stopped because their position is not changing. And at part 3, they're moving back towards the starting point, but at a faster pace. So you're going to want to fill that into your graph. Or not your graph, your text box there, I should say. Okay, and we want to think about, well, what's a velocity versus time graph going to look like? Okay, and it's important to realize that because we can have positive velocities and negative velocities, that we can have a graph that has space above and below that 0 point. And so if I'm thinking about that first segment, okay, that first segment, we have something, they're moving away from the starting point, they're moving at a constant pace, which means there's zero acceleration. So zero acceleration, they have that constant speed, means zero slope or a horizontal line. The second part, there's no movement at all, which also means no acceleration or zero acceleration. That means that there's zero slope again and a horizontal line. And then finally, our constant pace, but in the negative direction, is actually also going to be zero slope, so a horizontal line, but this time it's going to be below the origin. It's going to be in the negative part of our graph. And so if we think about the parts that correspond, the first part might look like this, where we have that red line being positive, but just horizontal, no slope. The second part being yellow, but right at the 0. And the third part being blue, but and horizontal, but down here below the 0 point on our axis. So again, we have several types of acceleration. We have constant, which will be a straight horizontal line on our velocity versus time graph. We have positive, which will be a positive slope. That's speeding up. We have negative, which will be a negative slope. That's slowing down. And then we have zero acceleration. And again, basically we have zero acceleration in all of these situations that you can see on this graph, but they may be horizontal lines in different spots. Okay, that's it for now.